Right, so for question number 1, okay, we're dealing with a mass on a spring. We know the mass is 4.3 kilograms, okay? We know the maximum speed is 1.8 meters per second. We know the spring constant is 5.4 newtons per meter, and we are looking for the displacement when it's moving at 0.95 meters per second. All right, so that's what we're looking for. So in other words, okay, we know information about when the mass is here at the equilibrium position, but we are looking for its speed when it is here. We're looking for its displacement here when its speed is 0.95 meters per second. We know that the speed here is 1.8. Oh, sorry, I guess 1.8 meters per second. All right, that's what we know. If they have something along these lines, give them a mark for givens. Since this question asks about 2 different positions in the oscillation, it's a law of conservation of energy question. Okay, it's not a Hooke's law question. It doesn't ask about acceleration. It talks about more than one point, so that's not what we're dealing with. Okay, so we've got EI equals EF, okay, and that's going to mean our initial is at the equilibrium position where our energy is only kinetic. Okay, so we're going to have EK initial equals EP final plus EK final. All right. So we'll give them a mark if they've got something along the lines of either one of those 2 things. When we're putting in our formulas here, what we're looking for is part of the potential energy final, because we're looking for the displacement here. So I'm going to bring the EK final over to this side. So I'll have EK initial minus EK final equals the potential final. And that will mean, whoa, put the pen down, dummy. Okay, so that will mean that we have to punch in our formulas here. So we will have 1/2 mv, and this will be our maximum squared, minus 1/2 mvf squared equals 1/2 kx final squared. All right, everybody follow there? Okay, I am looking for the displacement at that position. So I need to bring the 1/2 k over to this side. In fact, I just need to bring the k over because 1/2 is in every single term and it'll cancel off. Okay, so I'm going to divide both sides by k, and then I'm going to square root. All right, so that was 2 marks. We'll say 3 marks here. Okay, and we'll give them a mark for putting in the numbers correctly. So that'll be that x final equals the square root of 4.3 kilograms times 1.8 squared minus 4.3 times 0.95 squared divided by 5.4. Okay, so that's their 4th mark. Okay, so we got 4.3 times 1.8 squared, okay, minus 4.3 times 0.95 squared, okay, divided by 5.4, right? And then we have to square root that. All right, so we are looking at a displacement of 1.3, actually 1.4 meters. I think we only have 2 significant figures, yep. Okay, so 1.4 meters is our final answer. 5th and final mark there. Questions on number 1? Okay. So on number 2, I heard a lot of moaning and groaning about number 2. What kind of potential energy does a pendulum have? Gravitational. This is a roller coaster, except it's a pendulum. Okay, that's the only difference. I think that really threw people. Okay, for some reason they just forgot totally that when a pendulum oscillates back and forth, okay, it's converting gravitational potential energy into kinetic. All right, so our givens are that we know the maximum amplitude, okay, is 0.50 meters, and we're looking for the final height of the pendulum when the speed of it is 1.8 meters per second. All right, so what we're looking at here, guys, is essentially this. Okay, we're looking at essentially these two positions. Okay, so here our maximum amplitude is 0.5 meters. Okay, here we don't know what the height of it is, but we do know that at this point it's moving at 1.8 meters per second. All right, so those are the two positions we're dealing with. At this position, V equals 0. Yeah, this is its maximum amplitude. When it's at its maximum height, it's not moving anymore. Okay. All right, 1 mark for givens. 1 mark for recognizing this is a law of conservation of energy question. So we're looking at EP initial plus EK initial equals EP final plus EK final. So 1 mark there. We don't have any initial kinetic energy because we're at the maximum amplitude. What we're looking for is part of this. So we're going to bring EK final over. So we'll have the initial potential minus the final kinetic equals the final potential. That'll be M times G times H initial minus 1/2 MV final squared, okay, equals M times G times H final. All right, what can cancel right now? M. All right, now give them a mark if they got something like this. Okay, that'll be their 3rd mark. All right, so M's going to go away, and then I'm going to move G over to get H final by itself. So what I'll be left with is that H final equals G times H initial minus 1/2 VF squared divided by G. Okay, numbers plugged in, that's 9.81 times 0.5 minus 1/2 times 1.8 squared divided by 9.81. 1 mark if they've got something like that. So 9.81 times 0.5 minus 0.5 times 1.8 squared divided by 9.81. All right, so we're looking at a height here of 0.33 meters, because I think we only had 2 sig digs there yet. Okay, that's their final mark there. Questions on number 2? All right, give them a mark out of 10. Let them see it. Put it up here on this desk, please. Don't worry about it, Will.